Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's try to illustrate the meaning of the antiderivative of a function. In the previous video, we're able to define the antiderivative of a function given for any function, say f of x. Its antiderivative is f of x, capital 1, if it satisfies the condition that the derivative of our capital letter f of x function with respect to x is equal to your small letter f function of x. Okay? Or again, we can also say here this notation is equivalent to that. If this is satisfied, then this function here, the capital letter 1, is the antiderivative of our given function, which is the lowercase f. But what does this mean visually? We know that when we talk about derivative of a certain function, it is related to the slope of a tangent line at a specific point. For the antiderivative, what does this mean? Now, allow me to assign our function here, let's call it 2x. And allow me to graph this line on our Cartesian plane. We know that if as x is equal to 0, our f of x, which is our y, is also 0. And if x is equal to, let's say, 1, our f of x is actually 2. Okay? So plotting that here, allow me to plot that here. Hopefully that my lines are straight. Let's do it again. Okay? Let's just assume that my Cartesian plane are straight. So at 0, 0 is here. And at 1, let's say x is 1. You have here 2. Okay, let's add another value. So if x is, let's say, 2, our f of x is 4. So 2, and you have here 4. So we don't necessarily need the third one, but just to illustrate it better, let's try to come up here with a certain line. Okay, sorry for that. Let's use here a line. Pardon. Let me use a line here. Okay, that one. So that would be our line that represents our given function. F of x is equal to 2x. So this is our function here. Now, the concept of the antiderivative is actually related to the area under a certain curve. Let's apply a certain portion here. So let's just say any x at this region. Okay, any x. Let's say we have here x. We don't know that value. Let's just say somewhere here. X is somewhere here. So this, when we try to come up with this region here, okay, for our x, this region bounded here is the area between our line, which is connected to, again, it's related to our function f of x is equal to 2x, and the x-axis here. So this is the area for that. Now, the antiderivative is actually related to the area because when you look into this perspective, okay, when we try to come up with our x here point, of course, the value of this in our y as our x would be plugged in here. This would mean this is our function of x, right? That's our f of x, or let's say in this case 2x for every x value. Okay, general form, we don't have a specific value for x here, but the general form, as soon as we arrive to the value of x, the height of that certain figure would be f of x, which is 2x. And since we know that this is a straight line here, we have determined a certain triangle. The area of a given triangle, okay, of a triangle is identified as 1/2 base times height. Our base here corresponds to this distance, which stands for our x, and our height, as mentioned, corresponds to f of x. For all x's will be 2x. So that would mean that we have here 1/2 times your base, which is x, and then your height, which is 2x. Okay, so what is this equivalent to? As we take out 2 here, our area of this given region, the red one, okay, so let me use here the red one because since the red is what we've been using as we shade that one, it's actually equal to x squared. Okay? So this is the area of this region here. But take note, if this is considered as any function, and if we're going to take the derivative of that with respect to x, we will actually get here 2x, which is the original given function. This can be represented by f of x, and this stands for the antiderivative of the given function here. This is why we can relate antiderivative of a certain function as the area under the curve, or area of that is created by the graph of a certain function and our region here, the x-axis. Okay, so we can see here that the antiderivative of a function is related to the concept of the area. Take note that if you're going to pick another value here, x sub 1, and this graph here will increase further, the height here for your x sub 1 would still be f of x, but instead of that, x sub 1, which is also 2x sub 1, using that here, you will still get 2x. This corresponds now to the area of any triangular region that is bounded by our f of x and the x-axis here. Now, this is the basic idea on the consideration or the concept of the antiderivative of a function, and basically that's the use of the antiderivative, as we are going to look for some area of regions later on as soon as we are done with some basic rules on differentiation and some certain examples. This is how we illustrate the antiderivative of a function, which is related to the area. But this is not yet complete, because the antiderivative of a certain function do not just have f of x. We are going to introduce here a certain constant which is true for all. We'll have the next video for that discussion, because we are going to introduce now the notation for the antidifferentiation or the antiderivative of a certain function. Thank you very much for watching. So what are you waiting for? Subscribe now.